Good evening, ladies and gentlemen. It is my pleasure to introduce the first speaker in the highlight series. My name is Sias Mostert, and I'm the IPC co-chair for Cape Town and standing in for this year as well. Dr. Peter Martinez is our speaker. He achieved his PhD in astrophysics, I believe, in 1992. That's a mere 18 years ago. And I met him in 2003, where in Vienna, in Copious, where I got to know him a little bit better, and where we started a discussion on the South African space activity and why it was so uncoordinated. That led to the formation by the Department of Science and Technology of a national working group, where he was very actively engaged, and that was until 2008. And from that national working group, actually a number of activities sprang forth, of which you will see tonight a number of them. One is the space policy was developed, where he played a leading role in the formation of the South African space policy. There was the Soonbandila sat mission was approved by the national working group at the time of conception. And then one of the other outcomes of this national working group, which have subsequently been disbanded because the South African Space Agency has been is in a formation process, and you will also see some feedback on the process of the South African Space Agency. Then the latest milestone in Dr. Martinez's career has been from the July 2010, in fact this year, he has been appointed as the chair of the South African Council for Space Affairs, as a regulatory body in comparison to the Space Agency. So thank you. Let's give Dr. Martinez a good hand. Thank you.
Thank you, Sias, for that kind introduction. Good afternoon, ladies and gentlemen. It's a huge pleasure for me to be here, and a fantastic opportunity offered to us by the IAF to present the overview of South African space activities here at this event. I'm very excited to be here with my compatriots, and also enjoying very much being back in Prague. I've been to this city a few times, really beautiful city, and I enjoy my visits to Prague very much. The last time I was here was actually on the occasion of the IAU General Assembly in 2006. Some of you in the room would probably have been there as well. And this morning at the welcome ceremony, the venue that we were in was quite a historic venue, because that is the room in which the IAU voted that Pluto was no longer a planet. So you were in a historic place this morning. I hope the Congress Center puts up a plaque outside that says, this is where Pluto was demoted from being a planet. So lovely to be back here again. This is the outline of my presentation for today. I want to give you a historical overview of the development of space activity in South Africa. It's not generally known that South Africa has been an active participant in the global space enterprise pretty much since the earliest days of the space age, supporting mostly from the ground, of course, but in latter years also an active user of the space environment. So I'll give you a little bit of the history, and I will fold into that a survey of the facilities and programs that arose over the last 40 years or so. Then I want to talk about Soonbandila Sat, our recently launched satellite, as a capacity building mission, and then move on to say a few words about how space activities are organized in South Africa, and then end with some remarks about the new South African Space Agency, which is in the process of being established. So to begin with historical review of space activities in the country, if we go back to the earliest studies of space, that is astronomy, of course, you're talking about activities that go back to the 17th century, the 1600s, in other words, with a Jesuit priest who visited the Cape and took some early observations. Then later on, there was a French astronomer, Abbé de la Caille, who came down to the Cape and defined a number of southern constellations and did observations of stars. And one of the constellations that he defined is Mons Mensa, Table Mountain. It's the only geographical feature on Earth that is commemorated as a constellation in the night sky. And for those of you who plan to come to the IAC 2011 in Cape Town next year, you will have a chance to perhaps see the real thing. So this is a photograph of the South African Astronomical Observatory. It was the first institution, if you like, rather than, as opposed to individuals, the first institution concerned with studies of space. And it was established in 1820 by the British Admiralty. The institution performed many interesting activities during the 19th century, concerned with the studies of the motions and brightnesses of stars, was one of the first places in the world to use the technique of, at that time, the newly invented technique of photography for astrophysical applications. So the observatory has a long heritage of contributions. One of its 19th century contributions, for example, was the first measurement of the distance to the nearest star. So moving on then to the dawn of the space age. This is a photograph of a project that was called Moonwatch, I'm sure known to many of you here in the audience. South Africa was an active participant in Moonwatch, and you can see here a large number of volunteers making early observations of satellite transits that were then sent back to the coordinators of this project. And this group of, this photograph was taken at the South African Astronomical Observatory, the facility I showed you in the previous slide. In the early 1960s, NASA established a deep space station, Deep Space Station 51 at Hartbeespoort, not too far from Johannesburg. And this shows the 24-meter antenna that was set up at the time for the purpose of tracking their interplanetary and lunar spacecraft. And the station supported quite a number of missions over the years, perhaps the most notable of which is the ground support for Mariner 4, the first Mars flyby. And you see in this slide here a sequence of images taken during that historic flyby, beginning up there at the top left of the image and going around in the arc shown there. In the detail of the and you can see here the sequence of images that were taken by the spacecraft during the flyby. The inset here shows the detail of that first image there. So that was one of the highlights of the work done at DSN 51. But there were numerous other missions that were supported. The station played quite a role in lunar exploration. The lunar rangers, which were photo reconnaissance and impact probes, were supported from the station. Here you can see on the left some commemorative plaques for those. And the station even supported some of the Apollo landings. You see here a commemorative plaque commemorating support for the Apollo 15 mission. South African Earth scientists also participated in the 1970s in the scientific analysis of lunar soil samples returned by the Apollo program. Other interplanetary missions were also supported by that facility, such as the Mariner 5 flyby of Venus in 1967, and also a dedicated interplanetary mission, Pioneer 8, in 1967. In the mid-1970s, that station was transferred to the South African Council for Scientific and Industrial Research and was renamed as the Hartbeespoort Radio Astronomy Observatory, HARTRAO, and it has continued to operate to this day as a radio astronomy facility. You see in this photograph the dish which has been refurbished, resurfaced since the original installation. And you also see a laser beam in the photograph, another addition, a more recent addition to the station, also in collaboration with NASA, is a a satellite laser ranging program. This has been running at the station for quite some time. The station is currently operated by the National Research Foundation, which is kind of our equivalent to the National Science Foundation in the States. And the observatory is still Africa's premier space geodetic facility, which has the co-location of 3 of the 4 major techniques in space geodesy, namely VLBI, a very long baseline interferometry, satellite laser ranging, and GPS. The geodetic work of HARTRA helps to maintain the international terrestrial and celestial reference frames. There aren't many other nodes. In fact, I think this is the key node on the African continent, therefore, for recording the motion of the African plate. Right next door to HARTRA is a neighbor facility, nowadays known as the CSIR Satellite Application Center. This facility, actually, there was a precursor to this, which was called Minitrack. It was a group called Minitrack at Esalen Park, which was part of the then National Institute of Telecommunications Research. And in 1958, that group tracked Vanguard, the first American satellite. The Minitrack group moved to the Hartbeespoort site in 1960, and the site was initially set up by JPL, and it was operated by Goddard Space Flight Center until 1975. The facility continues to be the premier satellite application center on the continent. Its activities fall broadly into 2 categories. Firstly, a TT&C component, which comprises things like launch support, transfer orbit support, in-orbit testing, life cycle support, remote sensing, data reception, and also the facility hosts infrastructure for a variety of international clients. So not all of these dishes that you see here are dedicated South African dishes. There are some facilities that are operated on behalf of international clients. As far as the applications component is concerned, the SAC hosts the National Earth Observation Archive, which of course is a very rich source of data for us, particularly in studying things like climate change and so on. The facility also has sophisticated pipeline processing facilities, which basically starts with the data ingest and processes the data through to a catalog. And for the South African Soonbandila satellite, the catalog is set up in such a way that the end user can query the metadata, and if no images are available, it's possible to backwards task to a satellite, Soonbandila, to take an image. This, we are considering continuing with this kind of policy for our future national satellites, but that is still a discussion that is underway. The center also supports disaster management assistance by satellite, not only to South Africa, but to the neighboring countries in our region. And it has a number of activities that it's rolled out, such as, for example, near real-time fire monitoring and an issuing of alerts to the cell phones of farmers and park rangers. It also does things like an annual dwelling inventory to map changing settlement patterns. So a large number of applications that come out of here. It's not just a data reception facility. Now, moving forward to the 1980s, in the mid-1980s, South Africa began its first space program, and the objective of which was to develop a Earth observation satellite and a launch vehicle to deliver that satellite into orbit. This program reached an advanced stage of development, but was terminated in the mid-1990s when the need for, this was basically a military program, and it was driven by a need for remote sensing data during the Cold War period in the African continent. And with the end of the Cold War, the military mission for this program went away, and so therefore the program itself was terminated. There was an attempt to commercialize the satellite component of it as GreenSat, but this unfortunately did not succeed. So the facility was taken over by the Department of Communications and used for various research and training applications. You see here one of the tests of the launch vehicle, the RSA rocket. There were 2 suborbital flights, and there is one of the rockets can still be seen at the South African Air Force Museum. This is the satellite that was developed at the time. So, although that program did not result in any orbiting satellites, we do still have the facilities that were developed at the time. This is a photograph of what we call the Institute for Satellite and Software Applications. It's basically a satellite testing and integration facility. This is the main integration hall. You see here some of the equipment and one of the satellite models for the previous satellite. This facility was used to integrate and test the Soonbandila satellite, which I will show you in a short while. Here is a thermal vacuum test facility, which is at ISA. There's the standard tests for mechanical properties and electromagnetic testing and so on. So with the demise of the GreenSat project, there was a hiatus in terms of institutional space activity on a large scale. But fortunately, there was a group at Stellenbosch University that decided to undertake a microsatellite project known as Sansat. And this one actually did make it into space. It was a 64-kilogram satellite that was built by staff and students at Stellenbosch University. Here's a group photo of some of the people involved with that program. And I'm pleased to note that 2 of the people that were involved in that program are here at this Congress this week. So they've stayed in the game, so to speak. The satellite had 15-meter ground resolution and 6 bands, and it was launched in February 1999 on an American rocket as a secondary payload, and was operated from the Stellenbosch University campus until January of 2001. The project was very highly successful in terms of capacity building. Over 100 students were associated in one way or another with this project and had master's and PhD activities from the period 1992 to 2001 associated with this. You can see here an image of Valletta, the island of Malta, with the harbor of Valletta as taken by Sansat. So Sansat at the time, it was actually quite an advanced microsatellite in terms of the capabilities that it had. It had a full 3-axis control capability. I mentioned it at 15-meter resolution, and it also carried a GPS receiver and magnetometer and laser reflectors and an amateur radio payload as well. Then in the early 2000s, the astronomy community began the development of the Southern African Large Telescope. The telescope the telescope was commissioned in 2005. You see it illustrated here in this photograph. It is currently the largest single telescope in the Southern Hemisphere. And I stress single because, of course, the European Southern Observatory's VLT is much larger when the 4 8-meter telescopes are used together. The SALT's primary mirror is a hexagonal array, 10 meters across from flat to flat and 11 meters across from points of the hexagon. It's situated in Sutherland, about 400 kilometers from Cape Town by road. You see here a picture of the SALT dome. And also, this is the site of the Southern African Large Telescope, of the South African Astronomical Observatory, and it has the infrastructure, as is the case with SAC, the infrastructure at SAAO is attractive to many organizations wishing to conduct astronomy activities from the Southern Hemisphere, and indeed this facility has been used to provide ground support for a number of space missions over the years. South Africa is also a minor partner in the high-energy stereoscopic system. This is a large infrared array being built in Namibia, and we are involved on on the detector side of things, but as a fairly minor partner there. Then, more recently, there's been a development to bid for South Africa to bid to host the Square Kilometre Array project. This is an international project to build a radio telescope with a collecting area of 1 square kilometre, so certainly the largest radio astronomy facility ever built to date. It's currently still in the conception stage. And in order to build such a large facility, this will be a very distributed facility over a large extended area, you need large radio quiet zones. And so there aren't many places in the world these days where you can find such large radio quiet zones. And it turns out that the best places are places like Australia and South Africa. We are currently shortlisted together with Australia as one of the 2 potential host countries for this project. And in support of our bid, we have started our own large radio astronomy project called Meerkat, which is being built in an area of the country called the Northern Cape. And Meerkat is going to transform a typical, this is a typical view you would have of that part of the country, very desolate, not built up, and we're hoping to transform that into something more like this. The Meerkat array, we already have a 7-dish array in place. The aim is to finish the full array by the end of 2012 with some 50 to 70 dishes in the full array. So I've spoken quite a bit about ground-based space science and technology activities, and I wanted to do so because for us that was important. It was an important precursor to getting involved in the space segment side of things. So I now want to move on to the Soonbandila microsatellite mission. Soonbandila is a word in the local Venda language that means pathfinder, and for us this is a pathfinder mission that helps us to build capacity in the development and execution of a national space program. So just to give you some technical, some specifications for Soonbandila, the owner of the mission is the National Department of Science and Technology, DST. The managing entity for this project was the University of Stellenbosch, and the contractor of this mission was Sun Space. Now, I forgot to mention when I said that the Stellenbosch University built and launched the SunSat, and it turned out that there was an interest in potentially commercializing some of the technologies on SunSat. So since universities are good at teaching but are not really corporate institutions, it was decided to spin off a company called Sun Space to commercialize those technologies, and Sun Space was commissioned to build Soonbandila. You see here the mass of the satellite is, launch mass was 82 kilograms, and it has a variety of imaging and experimental payloads. Project budget was about 26 million rands, and if you want a euro figure, divide that by 10. So you can see that in euro terms, this certainly was a very inexpensive space mission. Again, for us, the emphasis was on capacity building, and this project resulted in 18 masters, 2 PhD graduates, and there were also 4 postdoctoral fellows who participated in the program. The ground station for Soonbandila is at Hartbeespoort, the facility I showed you previously. It was launched on the 17th of September 2009 into a 500-kilometer sun-synchronous orbit at a 97-degree inclination. Its expected lifetime in orbit is 3 to 4 years. Here's some more detail on the payloads. You can see the primary payload, an imager, with 6 bands in the visible and near infrared with a ground resolution of 6.25 meters. It has a swath width of 45 kilometers with off-nadir viewing capability, which of course means that your revisit times are effectively shorter. And it means that any point in South Africa can be revisited within 6 days. As with SunSat, there are a variety of secondary payloads, and these were contributed by university departments around the country, and also the Department of Communications. As I said, for us, the emphasis of Soonbandila was on capacity building. in all aspects of conducting the space program, including government. And what it did for our government was to familiarize us with all of the issues associated with the management of space activity, with interdepartmental and interagency coordination on space matters, on procurement issues, and also on the timescales for space activities. On the human capital development side, there were programs to facilitate master's and PhD training at several universities around the country, not only Stellenbosch University. The project was also used to develop the academic research community involved in space science and technology research, and it provided exposure and experience in assembly, integration, and testing procedures for a lot of our young engineers. The project also stimulated our industry. There were over 40 companies involved in the project. The satellite largely sourced from South African companies. Very few of the components on the satellite were procured internationally. And it also stimulated things like process and quality improvements in our industry, and it helped to build our heritage in the space industry. On the access to space side, it helped our government to familiarize itself with licensing and export issues, with issues around the transportation of a satellite to the launch complex, insurance issues, all of the issues around conducting a launch campaign and so on. So that was a very valuable experience for all the people that were involved in that side of the project. Then as far as operations and life cycle management, that phase of the capacity building has started with the launch of the satellite. We have in the past supported space missions of other countries, but never a mission of our own, and being fully responsible for all aspects of operations and life cycle management. And then finally, the Soonbandila also stimulated the development of all sorts of applications within the South African scientific and research community, applications to utilize data from the satellite for sustainable development. Soonbandila also helped us to build capacity in space policy issues. By being connected and familiar with all of the challenges of conducting a program in an emerging space nation, it helped us to focus our thoughts when we were planning our space policy. It also helped us to address or to understand and address all of the regulatory issues, such as licensing issues, the ITU frequency filing issues, the international conventions and so on that are all relevant when one is an active participant in the space arena. And then finally, the project itself was very successful at promoting wide space awareness in the country. So this is a picture of the satellite once it was integrated as a secondary payload onto a Russian Soyuz launcher. There it's already inside the fairing, so you obviously can't see the satellite. I have a little video which I hope will play. So this is the launch of Soonbandila. It was launched from Baikonur on the 17th of September 2009. So that was a very exciting moment for all of us in the space arena to finally see Soonbandila being lofted into space. And then, of course, we couldn't wait to receive images from the satellite. I don't have the time here to show you many images, so I will just show you this one of Cape Town, because that will be the site of the next IAC. You can see here, this is Table Bay, there's the harbor, the central city, and I just want to draw your attention to this circular feature here. This is the soccer stadium, which I'm sure many of you would have seen at least some of the games of the recent World Cup. It was a traffic nightmare for those of us who lived there, by the way. Okay, I now want to say a few words about the emerging South African space industry. I don't want this to be a catalogue of commercials for our companies, but I did want to just present to you some of our key players, and they are shown here on this slide. Our key industrial actors in the space arena are Sunspace, the company that built Soonbandila, that took the image you just saw. And Space Advisory Company, its holding company is Space Commercial Services. Now both Sunspace and Space Commercial Services are members of the IAF, I'm pleased to say. And if my compatriots from Telumat and Marcom are in the audience, I would like to encourage you to join the IAF before we host the Congress next year. Okay, so those are our industrial actors, and then we have on the government side, government acting as an enabler, and the principal department in this respect is our Department of Trade and Industry, the DTI, and they roll out their support for the aerospace sector through this Aerospace Industry Support Initiative, AISI, and I would recommend you to visit stand A6 in the exhibition. This is the AISI stand. You will recognize the logo there. And you can meet the folks from these companies and get an idea from them about their capabilities and what they are doing to help us develop our space arena in South Africa. So, sorry, I just want to... A few years ago, in government, we did a benchmarking exercise to see where we were in terms of our industrial capability. As we were starting our space program, we were wondering, do we have the industrial wherewithal, the capacity to start developing our own satellites? Obviously, with the construction of Sansa, we knew that there was some capability in the country, but we weren't quite sure how extensive that was. So we commissioned a study using a couple of major international aerospace companies from Europe to assist us, and this was a South African joint project, and some standard benchmarking methods were used that are used to assess the companies in the supply chains of these actors. And out of this, we were able to benchmark to compare South Africa against the other players. And this axis of the slide, the horizontal axis, shows space capabilities, technical capabilities, if you like, and the vertical axis shows heritage. And you can see here the leading space actors, the group of intermediate space countries, and then this group of emerging space nations here. And we were surprised when we saw the outcome of this study and tried to investigate whether this was real or not. And to our surprise, it was actually real, and it goes back to, it's a consequence of the very significant investments that were made in South Africa's first space program and the industrial capabilities that were developed to support that. And they've been dormant for some time, but a lot of the infrastructure and know-how is still in industry. And then, of course, more recent procurements in the aerospace sector. So this is where we were as of a few years ago, but our scientific and technical population, as is happening worldwide, is graying, getting older. And so that dot was, for us at that time, sliding slowly this way. So with our new space program, we are hoping that we will maintain this position, and of course our ambition is eventually to move upwards in that direction. Now, I want to say a few words about governance of space activities in South Africa, how we organize our space activities, because I appreciate that may be of interest to many of you, and not easy to find out if you're not well connected with the country. The overarching responsibility for space affairs in South Africa rests with the Minister of Trade and Industry, and the Department of Trade and Industry therefore has the mandate for implementing the Space Affairs Act. This is the statutory mandate that governs space affairs in South Africa. And you can see that it refers to supervising and regulating space activities, as in the Outer Space Treaty, states are required to supervise the activities of their national entities. So this supervisory function rests here. Monitoring the implementation of space policy and advising the minister in the development of such policy. Developing the domestic legal framework for space activities, the licensing regimes and so on. Ensuring compliance with our international obligations in terms of the Outer Space Treaties. And also taking the lead in intergovernmental discussions on space issues. The implementation side of the program rests with the Departments of Science and Technology, primarily, although not exclusively, because, of course, communications issues would rest primarily with the Department of Communications. But they are taking the lead in the establishment of our space agency, and their mandate comes from the South African Space Agency Act of 2009, and that provides them with the mandate to establish the space agency, and I will say a little bit more about that in a few minutes. So the Department of Science and Technology has developed a couple of strategies, which are, in a sense, sort of how-to implementation guides for the policy. It has developed a national space science and technology strategy and also a South African Earth observation strategy, and these documents are available on the DST website. So why are we pursuing space activities? Well, this summarizes it in a nutshell. We see space as an important tool to help us meet national development imperatives. There are various national policies in the various sectors like transport, science and technology and so on. And these various policies speak to the national development imperatives. And we realized, as C.S. Mostert said in his introduction, that we needed to have a better coordination of space activities in South Africa. So this convergence of South African space activities more or less pointed us in the direction of a space agency. So I now want to describe the South African space policy, or the salient features of it at any rate. Policy was launched in early April 2009 by the Minister of Trade and Industry, and that too is publicly available. The policy document itself is a fairly short document, but there are 4 other supporting documents that provide contextual background to the policy. The objectives of the policy are shown here in this slide. You can see that they speak to enhancing international cooperation, promoting enhanced space awareness at all levels. So when we say space awareness, we don't only mean the youth, we mean parliamentarians, politicians, so on. Developing and fostering our national space infrastructure. We want to strengthen our space science and technology base. And also very important for us is the issue of cooperative governance, because space activities are cross-cutting across a number of departments, and we needed to improve the coordination there. So the policy principles are shown in this slide. There are 6 basic principles that underpin the policy, and each of these principles was chosen for its contribution to economic growth and sustainable development. So the first principle is that we use space for peaceful purposes and for the benefit of humankind. The second is that we want to develop a robust set of appropriate space capabilities. We want to ensure that South African space users are responsible space users of responsible users of the space environment. This goes back to the supervisory function I referred to. We want to promote research and development in space science and technology, to promote greater levels of self-sufficiency and international competitiveness, and also to promote mutually beneficial cooperation with a variety of international partners, but perhaps also with an emphasis on the African continent. There are a number of other countries in Africa that are developing their own space capabilities, and we're very excited about the opportunity to work together with them to develop space solutions to Africa's problems. So if I just quickly look at how we're translating these policy objectives into practice, the objective of cooperative governance There we are trying to get the different government departments and agencies to work more efficiently with each other to reduce the sort of the silo effect that was in place before, where there were pockets of activity that were pretty much isolated from each other. Then in terms of developing adequate and appropriate space capabilities, we're looking at establishing the industrial base to provide the necessary capabilities. We're promoting space science and technology research in our universities and trying to encourage academic industrial partnerships to facilitate this, both because the industry can be a source of support, but also because it means that the research that's done is relevant to industry and its needs. So a huge emphasis on human capital, as I said before. In regards to access to space, our policy says that we will pursue at least 2 independent and comparable lines of access to space without prescribing what those are. So we are not at this stage contemplating as a national program the development of launch vehicles, but we are looking carefully at the issue of access to space and how to have assured access to space. In terms of strengthening the space science and technology database, I've already mentioned the importance of basic R&D. We have a number of national research and development institutes in the country, and one of the things that we were conscious of when we were developing the policy was that we did not want to be in a situation where the new space agency basically soaked up all of the scientific talent and basically left the other institutes and universities depleted. Our academic and scientific system is quite small, so we want to use the space program as a kind of catalyst to stimulate the development of industry and academia through the space agency acting in that sort of catalytic role. In terms of the infrastructure, I mentioned that we had this infrastructure that was developed for the previous space program with a hiatus of 15 years. It's, of course, parts of it have become outdated, so we are putting in place measures to bring up those facilities to speed, not only with the technology, but also with the people, the trained people to operate those facilities. And of course, as all of you know, the best way to maintain a facility in a peak condition is to actually use it intensively all the time and not to have periods of no activity. In terms of promoting the domestic space industry, we want to take measures to put in place a supportive regulatory environment that makes it easier for our companies to be competitive internationally and makes it more attractive for international companies to do business in and with South Africa. I mentioned the importance of promoting enhanced awareness at all levels. We consider it very important to engage with our politicians on a continual basis. And one of the things we're trying to do is to encourage our private sector to get involved in the space awareness activities. And I must say that our private sector has been extremely good at this. And we, from the government side, I think we've been very happy with the way that the government sector has been a big player in this. And then finally, we are enhancing our international collaboration. We've been increasingly active in multilateral fora, such as UN COPUOS, the Group on Earth Observations, CSIR, and so on. Just to give you a summary of the vision for our future space goal is basically for South Africa to become one of the leading nations in the innovative utilization of space technology to enhance economic growth and sustainable development, to improve the quality of life of our citizens. So we have a variety of goals that go hand in hand with that, but perhaps let me just advance to the next slide, which summarizes it pictorially. These are our key focus areas: environmental, resource management, health, safety and security, innovation and economic growth. So the program is going to deliver primarily in these areas, so that speaks to applications. But of course, applications need to be underpinned by technology, so there will be some effort, considerable amount of effort also going into supporting the technology base. And of course, technology is underpinned by basic science, so we do want to have a component of science and exploration in our space program. It will be predominantly applications oriented, but not exclusively so. And here I think this is where I would see that we would be particularly keen on opportunities for international cooperation to participate in things like the Global Exploration Vision. So this is just one of the many examples I could have chosen to show you the use of satellite data for applications. This is the South African Earth Observation portal, and it is South Africa's implementation of GEOS, the Global Earth Observation System of Systems. And this portal basically provides access to the metadata that exists in our country for satellite Earth observation, and it allows the user community to access the data wherever it may lie in the country. This is still a system that's under development, but we will feed all of our satellite data into the system, and it will be possible for users to query the catalogs via this portal without knowing where the data from the different satellites are. And I want to conclude with some remarks about the establishment of the South African Space Agency. Sadly, Dr. Sandile Malinga, who is the current caretaker CEO involved with the establishment of the agency, he could not be here this week because this is a period of very intensive activity. So he did ask me to give you his greetings, and he's very kindly supplied a few slides on the establishment of Sansa, which I will show for you. So the main functions of Sansa will be to implement the National Space Program, to advise the Minister of Science and Technology on national space science and technology issues, and to acquire, assimilate, and distribute space-derived data to the various state entities that require it. This, of course, does not mean that the agency will not supply data to non-state actors, such as the academic or other sectors. But this is as a state entity, it has a principal responsibility to support the other national entities, state entities. So the establishment timeline for Sansa is shown in this slide. The phase one is what we call the establishment phase, and that has run from the 1st of April 2010 and will run up to the 31st of March 2011, which is when our financial year ends. And basically this has been concerned with setting up the various governance structures of the agency, with arrangements for migrating various institutions from their current situation into the new agency. It's been concerned with strategic and business planning, all the sorts of issues that go into setting up a new enterprise, and not necessarily space-related issues. Then phase two will be what we call the foundational operating phase, and that will run from the 1st of April 2011 to the 31st of March 2012, so that will be next financial year. And on 1 April, the institutions that have been identified for migration into the space agency, namely the CSIR Satellite Application Center and the Institute for Satellite and Software Applications, the integration facility I showed you earlier, those two will migrate into the agency formally on 1 April 2011. And then we'll begin a phase of implementing the foundational plans and procedures. Now, we fully expect that these plans will need tweaking, probably considerably so in the first year, so there'll be a lot of monitoring and evaluation that happens during that period to improve our plans and procedures. And then finally, phase three will be when the agency enters into its full operational phase on the 1st of April 2012. And at that point, we expect to have a full implementation of all of the policies and procedures that were refined in year 2 of the establishment. So this, as I said, we're currently in phase 1. This shows the key milestones of phase 1, and you can see that the launch of Sansa, shown here in this box, it's not a point, I mean, it actually is a point event, but it's shown as a window here. And we all know in the space community that we rely on our political principles to launch space agencies. So things like the availability of ministers and timing of events has to have some latitude to allow for that. But we are hopeful that the agency will be established by the end of this year or early next year as on a sort of a limited operational level. So I want to end with a few slides about to advertise the 62nd International Astronautical Congress that will take place in Cape Town next year from the 3rd to the 7th of October, World Space Week. We are extremely excited about this because it is the first time in the history of the IAC that this Congress is coming to the African continent. We have been working very closely with the IAF Secretariat, with the former president, Jim Zimmerman. Is Jim here? No, okay. I should say Jim was the person that started twisting my arm a few years ago to consider a South African bid for the Congress, and I'm very glad that we have done so. But I should say that when we agreed to bid, that from the outset, we saw this as an African bid. We wanted very much this first Congress in Africa to benefit the whole of the African continent. So I want to repeat that again to all of my African colleagues who are here this evening. Please approach us. Feel free to do so. We would very much like to engage with you in the planning for this Congress to make sure that it is a great success, not only for the IAF, but for the African space community, and that it responds to our interests and needs. Now, I should say that the international space community has been incredibly supportive. There are a large number of international space organizations, not only the IAF and its traditional partners, the IAA and IISL, but a large number of other actors that have all come together to coordinate and align their activities in Africa next year to all basically build up to the Congress in Cape Town in 2011. So we're very excited about this. It's generating a lot of energy. We are planning to have a special, the 3 days leading up to the opening of the IAC will have an overarching theme, space benefits for Africa, and we will at that point bring together the outputs of all of these events that have been coordinated during the year leading up to the IAC into a single point to derive the sort of maximum benefit from all of these activities. The theme of the Congress is African Astronaissance, to reflect the fact that there are a number of emerging space actors on the continent. You see here the website, www.iac2011.com. And this is a picture of Cape Town. For those of you who haven't been, I can strongly recommend it. It's a really very beautiful city. The Congress Center is shown here, so you can see it. Congress will take place in the heart of Cape Town and in a very nice part of the city. This is a very nice touristic harbor development. So for those of you who are used to perhaps not seeing the Earth from the bottom, but you want to locate yourself looking downwards from above, that's where it is, again, with the Soonbandila image. So thank you very much for your attention and for the invitation to speak to you this evening. I hope you found these remarks informative. Thank you.